So in today's lesson, we are simply going to look at a linear number pattern. Well, that's how we call it in grade 10 and 11. But you need to know that it actually has a special name which is stored in a cool, dry place and of course kept out of reach of children. So we simply call it an arithmetic sequence when we get to grade 12, but it's actually the same thing. So this question that you see on the screen, I actually got it from a past exam paper from grade 11. So some of these questions here, I'm going to approach them in two ways. A way that satisfies a grade 11 learner, as well as another way that satisfies a matriculant. Well, as a matter of fact, if you're doing grade 12, you have two choices. You can either proceed doing these questions the grade 11 way, or you can adapt to change and do it the grade 12 way, all right? So then, let's get down to business. Well, here they say consider the linear number pattern -5, -9, -13. And this pattern goes on all the way to infinity. The first question says we need to write down the next two terms of the pattern without determining the general term. That is important. And the next one says now determine an expression for the nth term of this pattern and then calculate the value of n for which the nth term will be -141. In other words, determine the position of a term that has a value of -141. All right? Well, let's go to the whiteboard and easily destroy this one. So then we'll begin by writing the pattern. They said to us we have -5, -9, and we have -13. And of course, this goes on all the way to infinity. In order for us to determine the next two terms, we are going to use the fact that a linear number pattern or an arithmetic sequence actually has a constant difference between the consecutive terms. In other words, between the terms that follow each other, one directly after the other. So now, if we take term number 2, which is -9, we subtract term number 1 from it, which is -5, we simply get -4. And if we say -13 minus -9, well, we simply get -4 once again. But this is what I want you to realize. In order for you to get term number 2, you actually said term number 1 plus the constant difference. In order for you to get term number 3, you actually said term number 2 plus the constant difference, which stands to reason that in order for you to get term number 4, you are simply going to say, well, I'm going to take term number 3 and add it to the constant difference. So when you say -13 plus -4, well, you simply get -17. And you go to this -17 and you add -4 once again, and you get -21. And when they say to you, write down the next two terms, please show them as if it is a sequence like that. Of course, you won't be completing this sequence. You'll be writing this on a new page. Not really a new page, a new line. Yes, that's what I wanted to say. So yes, please write them as a sequence. In other words, you'll be writing it like this: negative 17 and negative 21. All right? Please write it like that. Awesome. So now we know how to determine the next two terms without determining the general term. Now we need to find the general term of this pattern. So we are going to do this the grade 11 way first. We know that this is the general term. For a linear pattern, we say Tn equals Bn plus C, where B is the constant difference, which is this one. So now we come and say, okay, fine, we have negative 4n, and then we say plus C like that. All right? Then in order for us to find the value of C, you can substitute any term that you want here. Well, it's always easy if you substitute term number 1, all right? Yes, it's always easy if you substitute term number 1. Now, what is the meaning of this? Well, you say Tn, which is term number 1, it actually has a value of negative 5, but then it is at position 1. And then you say plus C. Then this one times that, we get negative 4. And if you take your negative 4 to the left, it becomes positive. And negative 5 plus 4, well, we simply get negative 1, all right? So our value of C is negative 1, which means that our general term, Tn, will simply be negative 4n, and then we say minus 1. This is the grade 11 way, all right? Okay, fine. Well, by the way, you actually need to specify what is the constant difference. So before you can say what, please tell us that the constant difference is negative 4, all right? Because there's actually a mark for saying this. So please say that. But if you want to do this the grade 12 way, you know that an arithmetic sequence is defined as a plus n minus 1, and then you say times d, where a is the first term. So you say, well, the first term is negative 5, and then you say n minus 1, d is the constant difference. So your constant difference here is negative 4. And now it's time for you to simplify. Well, you simplify by distributing this negative 4. So negative 4 by n, that is negative 4n. Negative 4 by negative 1, that's positive 4, which means that our general term will simply be negative 4n, and then you say minus 1, all right? Yes, that is how you determine your nth term. Well, this is where another mark will be if you did it the grade 11 way. What about if you did it the grade 12 way? Well, for substitution as well as for telling us that. Now that you know your general term, you can now determine the value of any term, right? For instance, you can now determine term number 50, because you can simply say, well, I have negative 4 here, and I can substitute my 50 and then say minus 1. So that's the beauty of the general term. It is a formula that represents all the terms on that number pattern. Right. Then the next question said we need to calculate the value of n for which the general term will be negative 141. So I'm just going to write my general term here for the sake of optimizing space. Right. Okay, fine. So, yes. So here we are looking for the position of a term of which the value is negative 141. So we simply say, okay, fine. Negative 141 is equal to 4n. And then we say minus 1 like that. Then we take this one to the left, it becomes positive. So now we are left with negative 4n, which is set equal to negative 140. Yes, I wanted to say that. Then when you now come and say 140 divided by 4, because the negatives will cancel out, then we find that n will simply be 35. This means that the value of a term that is at position 35 is simply going to be negative 141. So yes, that is what we are actually saying. All right. So the only difference here was finding the general term. Then everything else was exactly the same as how you know it. Now let's look at the next one. The next one says, in a linear number pattern, the first term is x and a common difference or a constant difference is 5 less than the first term. Listen to that. The constant difference is 5 less than the first term. Well, Madlala's age is 5 years less than, maybe let's say, I don't know who I can say. Who am I 5 years younger than anyway? But nevertheless, if I'm 5 years younger than someone, it means if we know that the age of this person is 50 years, then it means my age will actually be 50 years minus 5 years. Do you see that? My age is 5 years younger than his, or 5 years less than his age. So what this means is, in order for you to get the constant difference, you are just going to subtract 5 from x. That's the meaning of this statement. Now, if we know that the first term is x and the constant difference is x minus 5, then the question says, calculate the value of the first term if it is given that the sum of the first 3 terms of this linear pattern is 63. And this is for 5 marks. Imagine 5 free marks. Well, let's talk. We know that the first term is x. We are going to begin by doing this the grade 11 way. So the first term is x. But then the question is, what is the second term? I don't know what is the second term, but I know that the constant difference is x minus 5. And I know that in order for me to get term number 2, I have to say term number 1 plus the constant difference, which stands to reason that term number 2 will actually be 2x minus 5. Do you see that? Of course you do. Then now we come and say, how then do I get term number 3? Well, in exactly the same way. The constant difference is still x minus 5. So it means I go to this 2x minus 5 and I add the constant difference. And so I simply get 3x minus 10. Of course, this sequence goes on, but I'm actually interested in the first 3 terms, all right? Now I have to add those terms and equate the sum to 63. So I say, okay, fine, this is the first term. I add this to the second term. I add this to the third term. Well, the brackets are not really compulsory. They're not really necessary, honestly speaking. It's just for formality to show that it's 3 different terms, but even if they are not there, the meaning is not compromised. No, it still means exactly the same thing. But it's always nice if you put your brackets. Now we say, well, this entire thing is set equal to 63. And collecting our like terms, x plus 2x plus 3x, well, that is 6x, negative 5 minus 10. Well, that's actually negative 15. And we set this equal to 63. Then we take our 15 to the right. So we have 63 plus 15. We get 78. And we divide both sides by 6. So we find that x is going to be 13. Then we can conclude and say, well, therefore, the first term is simply 13, like that. So this is when you did it the grade 11 way. But if you wanted to do it the grade 12 way, then you understand that it's actually an arithmetic sequence where A is equal to x. A is the first term, and your constant difference is x minus 5. And they tell you that the sum of the first 3 terms is 63. So then you can state your formula for finding the sum and say, well, the sum of the first number of terms equals n over 2 times 2a plus n minus 1 times d, like that. But then you know that you're trying to find the sum of the first 3 terms. So you can now say, well, I have 63 there. I'm looking for the sum of 3 terms. Well, I actually have it, but I'm looking for, what is it I'm looking for anyway? I'm looking for x, right? And then, well, our a, which is the first term, it's x. The number of terms is 3. The constant difference will just be x minus 5. And then we can close our bracket. And right away, we really hate fractions. So we want to destroy this fraction. You can either divide both sides by 3 over 2, or you can multiply by the reciprocal on both sides, which is 2/3. And 63 times 2/3, we get 42. Then on the right-hand side, we now have 2x here. 3 minus 1, that is 2. Then now we can distribute the 2. So we get 2x minus 10. Then we collect the like terms. So on the right-hand side, I have 4x, but I choose to write it on the left. I take this 10 to the left-hand side, it becomes positive. So now I have 52 on the left-hand side, but of course I choose to write it on the right. And now I say, well, 52 divided by 4, I get a solid 13. So the bottom line is an arithmetic sequence is just a linear number pattern. Well, there is no difference between the two. The difference is just how you write these things out. But yes, the arithmetic one is a little bit exciting because you get to find the sum of as many times as you like due to the presence of a formula compared to, I don't know compared to what, but yes, that's what I wanted to say. So thank you so much for watching, everyone. I really hope you enjoyed the lesson. But then the question is, if you were to write it the grade 11 way, where would the marks actually be? Well, for telling us that term number 1 is x, which is something that we didn't specify in this case. Not really that telling us term number 1 is x. For stating the constant difference, okay? Yes, we should have explicitly said that the constant difference equals x minus 5. It's very wise for you to write this down, you know? Yes, it's very wise. Tell them what is the constant difference and tell them what is term number 1. It's very much wise to write it because there's a mark for saying this and then there's a mark for finding term number 2 and term number 3. In other words, for both of these, there's a mark for that. There's also a mark for equating the sum to 63. And there's a mark for simplifying this and of course for telling us the answer there. Yes. I'm just not sure about the mark allocation if you did it using the grade 12 way, but most definitely you'd get a mark for the constant difference. For substituting into the correct formula should be, and for simplification as well as your answer, that makes it 4 marks. So maybe you'll get 2 marks for using the correct formula, for substituting into the correct formula. That's what I wanted to say. Well, more or less, that should be your mark allocation. So yes. Thank you so much, everyone, for watching. Let's see you in the next one.